So the natural growth law describes unbounded exponential growth. And the equation is dp dt is k times p. Now k is a relative growth rate. And initially the population starts with a certain number of individuals, and we call that p0 or p naught. Now the solution from a previous video is that p at t is p naught e to the kt. And the doubling time is t2 is log 2 over k. And so we have an example here of E. coli. E. coli is a canonical example of something that can grow very quickly on a petri dish. It can be described by the natural growth law, and the relative growth is about 1/20th per minute. And so the initial condition is, in our case, is P0 is 60 cells. And so the question asks to write down the natural growth law and the solution. Well, we have it right here. We just have to identify that k is 1/20 and p naught is equal to 60. And so our natural growth law is dp dt is 0.05 p. P naught is equal to 60. And then the solution is p at t is 60 e to the 0.05 t. So we're just plugging in the value for p naught, 60, and for k, 1/20th. The doubling time is t2. It's going to be log 2 over k, which is log 2 over 0.05. The population size after 24 hours is kind of astounding, actually. So we can plug in the formula and say p at 1440 minutes is equal to 60 e to the 0.05 times 1440. So that turns out to be about 10 to the 33. Okay, it's this like massive number. It would fill the world many times over. And this shows that unconstrained exponential growth, as described by the natural growth law, will just take off and take over everything. And in fact, this was the basis for a very early novel by Michael Crichton called The Andromeda Strain, where there was this bacterial strain which escaped and got out into the wild and started to take over the world. And you could see that this could lead to a lot of suspense.